The dry end of the soil moisture release curve is probably not very useful when it comes to plant studies, but it's really useful when it comes to understanding soil mechanics and internal processes within soil like cation exchange capacity and shrink soil capacity. Before the VSA was around, we didn't really think there was hysteresis on the dry end of the moisture release curve, and hysteresis is that phenomena that there is a difference between the wetting and the drying curve. And the way that works is the VSA uses dry desiccated air to dry the sample down, and we measure that change over time as it's drying the sample. And for the wetting curve, we pass air that is close to saturation over the sample, and the sample slowly absorbs the moisture out of the air, and we measure that change again. And at the same time, we're measuring both water content and water potential of the sample. The VSA is capable of measuring in the range of about -10 megapascals down to about -300 megapascals. And within that range, it measures several hundred data points. We started measuring these soil samples and we found, wow, there is actual hysteresis on the dry end as well. We just didn't have the tools before to be able to see that. The thing that excites me the most about the VSA is the fact that we couldn't make this measurement before. The level of detail that we get on the dry end of the soil moisture release curve wasn't possible before. And now we can measure it, and now we can use that to better understand these different processes in soil. And that's gonna open up a lot for the science and for pushing the science further in the future.